When diplomacy collapsed behind closed doors, a hidden military convoy became the price paid on the battlefields. On January 20th, within minutes, a convoy carrying tens of millions of dollars in military hardware was reduced to twisted metal and ash. More than 50 personnel vanished from the battlefield, and a strike zone nearly 40 meters wide burned through the forest floor. No official statements followed. No responsibility was claimed. What triggered it all was not a missile launch, but a single decision made behind closed doors. Stay with us, because what happened next explains everything. For 11 days, a covert diplomatic channel operated between Kiev and Moscow through an Asian intermediary. The proposal was direct. Russia would suspend the transfer of new long-range weapons. Ukraine would pause deep strikes beyond the front line. There were no documents and no public records. Only encrypted exchanges routed through secured systems. At 1:32 a.m., the Kremlin delivered its final response. There was no counteroffer and no delay request. The message contained 14 encrypted characters, a formal rejection under Russian diplomatic protocol. The meaning was clear. Escalation was approved. Kiev had anticipated this outcome. 6 days earlier, Ukrainian intelligence calculated a 78% probability that the talks would collapse. A contingency plan was prepared in advance and locked inside the command network under a single designation: Silent Forest Phase 0. It was not an authorization to strike. It was an authorization to observe. Operators were instructed to monitor transport corridors that did not carry standard Russian logistical identifiers. Priority shifted from known targets to movement behavior. Within minutes of the rejection, 3 Lantern satellites adjusted orbital scheduling. Surveillance systems transitioned from reactive tracking to predictive analysis. No reply was sent to Moscow. Instead, Kiev began systematic monitoring. 39 minutes later, analysts detected an unidentified ground movement entering a secondary route near the border. The plan had found its opening. At 2:11 a.m., a Lantern reconnaissance satellite detected movement along a secondary transport corridor south of Belgorod. This was a road missing from Russia's active logistics registry. 17 vehicles were advancing in tight formation without unit identifiers, encrypted call signs, or registered convoy codes. That alone triggered an immediate alert. The anomaly deepened as analysts measured the spacing. Each vehicle maintained an exact distance of 27 meters. Speed fluctuation across the column never exceeded 1 kilometer per hour. This level of precision did not come from human drivers. It came from algorithmic navigation. Thermal imagery revealed another red flag. Engine heat output registered 42% below standard Russian military transports. Exhaust dispersion had been deliberately reduced, shrinking aerial detection range by nearly 50%. The convoy was engineered to remain unseen. Payload modeling estimated more than 430 tons of combined mass. This included fuel reserves exceeding 12,000 liters, volumes associated with forward deployment, not routine supply. Inside Kiev's command center, tension hardened into anger. Every kilometer the convoy advanced expanded its potential strike radius deeper into Ukrainian territory. If it reached the forest belt ahead, the interception probability would fall below 20%. This was not logistics. It was escalation in motion. The question was no longer what was being moved, but who had dared to send it. Inside Ukraine's underground command center in Kiev, intelligence analysts replayed the satellite feed frame by frame. Every image captured by the Lantern system was processed through Ukraine's military AI network. This is the same system used to track missile launches and drone routes along the front. What the software uncovered was alarming. Several transport containers carried markings that had been deliberately scraped away and repainted. To the naked eye, they looked random. But when Ukraine's AI reconstructed the missing characters, the sequence matched industrial transport codes used by Norinco. Norinco is China's state-owned defense manufacturer. The room went silent. Ukrainian analysts immediately compared the materials. The container walls were built from heat-treated alloy not used by Russian factories. Steel density measured 11% higher, a specification designed to stabilize solid fuel weapons during long movement. Then came the decisive match. Internal mounting frames aligned precisely with known transport structures used for DF-11 short-range ballistic missiles. Statistical analysis placed the probability of coincidence below 0.3%. Each launcher was capable of carrying a warhead weighing more than 900 kilograms. The effective strike range approached 300 kilometers. If these systems reached deployment positions, multiple Ukrainian cities would fall within immediate threat range. This was not indirect support. This was Chinese-built firepower moving toward the battlefield. And with every kilometer the convoy advanced, the clock began counting down. At 2:41 a.m., once the DF-11 identification was confirmed, Ukraine's command center shifted into emergency planning mode. The question was no longer what the convoy carried, but how long Ukraine had before it disappeared. Ukraine's military AI immediately began modeling the convoy's possible routes. Within seconds, 6 movement scenarios were generated using terrain elevation, fuel load, engine temperature, and road condition data. Every outcome delivered the same warning. If the column entered the eastern forest belt ahead, satellite visibility would drop by nearly 60%. Interception probability would fall below 18%. At that moment, the convoy would effectively vanish. At 2:44 a.m., an MQ-9 Reaper was launched from a forward airstrip under emissions-restricted protocol. The aircraft climbed to 9,200 feet, using electro-optical and infrared sensors to shadow the convoy without exposing its position. Each minute, the Reaper transmitted more than 320 gigabytes of live telemetry back to Kiev. Heat patterns, vibration signatures, and radio leakage were processed in real time by Ukraine's targeting AI. At 2:58 a.m., the system detected a critical vulnerability. Based on fuel consumption rates and ambient temperature, the convoy would be forced to slow or pause within 20 minutes near an abandoned logistics site. That location became Ukraine's final window. Miss it, and the missiles would be lost. At 3:03 a.m., while the convoy continued moving north, 2 modified MTLB vehicles were already in position less than 5 kilometers from the highway. Hidden beneath thermal camouflage netting, their engines remained cold. No radar, no active emissions. To Russian sensors, they did not exist. Inside each vehicle operated a newly deployed Ukrainian electronic warfare system known as Echo Trap 3.1. Unlike conventional jammers, it did not block enemy signals. It captured them. At 3:07 a.m., Russian Orlan-10 reconnaissance drones entered the area, broadcasting wideband jamming pulses across the corridor. The signal strength was enough to disrupt electronics within a 10-kilometer radius. Echo Trap responded instantly. The system recorded the incoming frequency, inverted the waveform, and transmitted it back along the same path. Within seconds, Russian jamming signals began colliding with their own reflections. The effect was catastrophic. Navigation data inside the Orlan drones drifted by more than 280 meters. Altitude readings fluctuated. Target coordinates contradicted each other in real time. For 141 seconds, Russia's local electronic defense grid went blind. During that window, Ukrainian systems regained full clarity. At 3:11 a.m., Kyiv's command center received a clean tracking lock on the convoy's projected halt point. The trap was now armed. All that remained was for the target to step inside it. At 3:17 a.m., the convoy slowed as it approached a narrow forest passage ahead. The road tightened, tree cover thickened, and vehicle spacing compressed to less than 20 meters. This was the point Ukrainian planners had been waiting for. Satellite imagery showed the column adjusting formation, preparing for a short halt. Fuel consumption indicators spiked as drivers reduced speed, forcing engines to operate inefficiently in the cold night air. Ukraine's targeting AI updated its model. Total onboard fuel was estimated at more than 11,000 liters of diesel, distributed across multiple transport vehicles. In this confined terrain, that amount alone could trigger a catastrophic chain reaction. Radio monitoring detected irregular transmissions from one vehicle near the center of the column. Its signal pulse repeated every 0.4 seconds, a signature consistent with a mobile command unit. 3 adjacent launch carriers showed elevated thermal vibration, confirming solid fuel missile loads at maximum capacity. If ignition occurred here, the blast radius would extend well beyond the road itself. Inside Kyiv's command center, confirmation lights turned green across multiple systems. The convoy was now fully inside the calculated engagement box. At 3:18 a.m., the final coordinates were locked. The message transmitted was short: execute. Above the tree line, something began to rise. At 3:19 a.m., the order was carried out. From concealed launch points less than 4 kilometers from the road, 24 FP-5 kamikaze drones lifted into the night air. Their ascent was silent. Electric motors were tuned for low acoustic output, barely detectable beyond 200 meters. Each drone weighed just over 4 pounds, carrying a shaped charge slightly above 2 pounds. Individually, they were insignificant. Together, they formed a lethal weapon system. The swarm climbed to 200 feet, synchronizing through laser pulse telemetry rather than GPS. Guidance data refreshed 22 times per second, allowing every unit to adjust position without emitting radio signals. Ukraine's combat AI immediately divided the swarm into attack layers. 9 drones were assigned to fuel carriers. 8 were routed toward DF-11 transport vehicles. 7 locked onto the command and escort units. Russian radar operators detected dozens of returns at once, but the signals conflicted. They overlapped and multiplied across the screen until real targets dissolved into noise. Within seconds, the swarm accelerated. Flight speed increased to 120 kilometers per hour, maintaining formation despite tree cover and terrain shifts. The drones descended in coordinated angles, approaching from multiple vectors to overwhelm defensive reaction time. From the ground, there was no warning, only a sudden mechanical whine slicing through the forest air. Then, the first impact point appeared on Ukraine's targeting display. The strike had begun. At 3:21 a.m., the first FP-5 drone struck. It penetrated the side of a fuel carrier, transporting more than 600 liters of diesel. The explosion produced a fireball rising nearly 20 meters, instantly illuminating the forest corridor. 7 seconds later, 2 additional drones impacted adjacent vehicles. The heat surge ruptured fuel lines and ignited a secondary blast that rolled through the convoy. The chain reaction had begun. At 3:22 a.m., FPVs assigned to missile transports reached their targets. Shaped charges punched directly into DF-11 containment sections. Solid fuel ignited under compression, releasing energy faster than any conventional detonation. Shockwaves traveled at over 1,700 meters per second, tearing vehicles from their frames. Metal fragments became airborne projectiles, shredding everything within range. Russian crews attempted an emergency response. A nearby Pantsir S-1 battery launched 4 interceptors, costing nearly $90,000 each. But corrupted targeting data sent all missiles into empty air. Within 3 minutes, 11 transport vehicles collapsed into burning wreckage. Ground temperature at the epicenter exceeded 1,450 degrees Fahrenheit, hot enough to deform steel suspension systems. By 3:24 a.m., the convoy no longer existed. Only flame, pressure waves, and twisted metal remained. In less than 180 seconds, a moving threat worth tens of millions had been erased. The forest fell silent once more. At 3:40 a.m., the first Russian emergency units reached the blast site. They arrived late. Electronic interference still disrupted communications, and navigation systems continued reporting conflicting coordinates. What they found was total destruction. The forest clearing had been transformed into a crater more than 12 meters wide and nearly 4 meters deep. Burned vehicle frames lay scattered across the road. Some fused directly into the soil. Thermal sensors recorded residual ground temperatures above 900 degrees Fahrenheit, more than 15 minutes after the explosions. Initial recovery reports listed at least 50 personnel dead or missing. Several bodies were unidentifiable due to extreme heat exposure. More troubling, some remains were found without standard Russian insignia or documentation. By 4:10 a.m., independent satellite systems began passing overhead. Lantern confirmed full destruction. Commercial imagery captured identical coordinates within minutes. At 5 a.m., Russian state channels labeled the incident a fuel accident. The explanation collapsed almost immediately. Satellite imagery revealed multiple impact points consistent with aerial strikes, rather than internal failure. No ammunition or missile components were recoverable. Nothing could be salvaged. The damage was too precise. The evidence was too visible. What happened in that forest could not be buried and could not be explained away. The consequences were no longer confined to the battlefield. They were about to reach the world stage. What happened in that forest was not simply a successful strike. It was a warning. In less than 4 minutes, a Ukrainian operation costing under $30,000 erased a weapons convoy valued at nearly $100 million. The destruction ratio exceeded 1 to 3,000, a number once considered impossible in modern warfare. No fighter jets were used, no cruise missiles were launched, no air bases were exposed. Instead, the battle was decided by data. Small satellites provided constant visibility.
Look up ahead.
Artificial intelligence predicted movement instead of reacting to it. Electronic warfare did not overpower enemy systems, it reflected them. And drones, no larger than birds, delivered precision once reserved for strategic weapons. For decades, military power was measured by size. Larger armies, heavier armor, more expensive missiles. That logic no longer holds. The convoy had protection, it had escorts, it had layered air defense. Yet none of it mattered once decision-making speed outpaced human response. From detection to destruction, the entire engagement unfolded faster than a command chain could react. Analysts would later identify 5 decisive factors: persistent satellite coverage, AI-driven prediction, reflective electronic warfare, coordinated drone swarms, and timing measured in seconds rather than minutes. Together, they formed a model no traditional doctrine had prepared for. This was not improvisation. It was a system. And that realization unsettled military planners worldwide. Because if a nation under pressure could achieve this level of precision with limited resources, the future of war changes. Future wars would no longer belong to the richest or the largest. They would belong to those who think faster. The battlefield had not just expanded, it had evolved. And nothing after this night would ever be fought the same way again. What happened that night was more than a strike. It was a message written in silence, delivered through algorithms, satellites, and machines no larger than a backpack. The world may argue over politics and denials, but the battlefield has already given its answer. If wars can now be decided in minutes by data rather than divisions, then the future will look very different from the past. What do you think this means for the conflicts ahead? Leave your thoughts in the comments below. If you found this analysis valuable, don't forget to like the video, subscribe to the channel, and turn on notifications. The next battlefield may already be forming right now.